Let's get started. So today we'll discuss SQL versus NoSQL. So SQL databases, also popularly known as RDBMS, Relational Database Management System. So these are the databases which store the data in a structured manner. So what can be structured data? So imagine like employee details, employee ID, name, uh, date of joining, date of birth, and maybe a department, whatever. So the data that you can imagine to be of tabular format, where you can imagine the data like in rows and columns, those data are known as the structured data. And basically RDBMS stores mostly the structured data. And then let's talk about now NoSQL databases. So NoSQL databases are the group of databases which does not follow any schema. So these databases can have unstructured data. Now, now let's see what is the criteria for choosing the SQL versus NoSQL. So criteria for choosing SQL versus NoSQL. So before starting with the comparison, I'll give you a hint. In system design interviews, always prefer to use the NoSQL databases over SQL. This does not mean that SQL databases do not have any use and in all the scenarios you are going to use NoSQL databases. It just my recommendation is that generally in interview always prefer to use the SQL data NoSQL databases over SQL databases, and I'll give the explicit reasoning for that at the end. So what exactly is the reason behind suggesting this particular thing? Now let's go towards the comparison for choosing SQL versus NoSQL. So first is the relational, that is the structure of data. Structure of data. So if your data is structured, that means you can imagine the data in rows and columns, right? Probably Excel kind of structure, right? Rows and columns. Then you can prefer to use SQL databases. Okay. And if the data is non-structured, then you can prefer to use NoSQL databases. So example of unstructured data will be, let's suppose Amazon catalog data. Okay. So each of the product has different attribute. Let's suppose mobile phone, right? So it will have Bluetooth version. It will have let's suppose GSM band, 5G compatibility, and other stuff, right? And on the other hand, let's suppose apparels, right? These will have size M, L, XL, right? Those things. So these two are totally different. No matter what you do, you cannot fit all this data in a single structure, right? You cannot have a superset of all these attributes. And these attributes are ever growing, right? Let's suppose tomorrow you have made a superset and suddenly a new attribute comes up, right? So these data cannot be stored in a structured manner, right? So for these use cases, we will always prefer to use the NoSQL databases. Now, now let's talk about the second aspect, that is the scalability. So relational databases are vertically scalable and NoSQL databases are horizontal scalable. So that means whenever we use the RDBMS, right, we can only scale in a vertical manner. That means we can put more resources into the same server, increase the RAM, increase the CPU, right? But in the non-relational databases or the NoSQL databases, we can horizontally scale. That means we can add different servers, right? Multiple servers we can add. We can horizontally scale. In the initial terms, you won't feel any difference between vertical scaling but and horizontal scaling, right? But the problem comes up whenever the size goes exponentially, right? At a time you will hit the maximum, and at that particular time you won't have the capacity to even expand further on the vertical, right? The cloud providers won't support that vertical scaling after a certain point, but horizontal scaling has unlimited scalability. So if your data volume is too huge, the preference will go to the NoSQL databases as compared to the SQL databases. Plus, there is one more point. Generally, for the smaller set of data, SQL databases tend to perform relatively, tend to give the result in very less time. So probably even single digit millisecond, or probably even microsecond. But as the data volume goes up, the relational databases tend to perform much slower. So that means if the data volume is too high, right, there are chances that the SQL databases will perform poorly as compared to the NoSQL databases. And the NoSQL databases performance does not degrade with the increase in the data size. Now, let's talk about one more point. Generally, you will see the recommendation on the ACID properties. ACID stand for atomicity, consistency, isolation, and durability, right? So, you must have heard that SQL databases or the relational databases are ACID compliant. That means if you want to achieve the strong consistency, so or if you want to achieve the transactional query, like let's suppose you have two bank account, okay, and you want to transfer fund from one account to other, right? So the query will look like it will debit from this account, it will credit into this account. So these two query should be wrapped under a single transaction, right? It should not happen that the debit will happen but the credit won't happen, or vice versa, right? So either both of them should succeed or both of them should fail. So this was one of the strong use cases for the using the relational databases. But nowadays most of the NoSQL databases are also ACID compliant. So even the DynamoDB, that is one of the most popular NoSQL database, provide the transactional read and write. So nowadays, more and more NoSQL databases are also supporting the ACID property. So probably, in my opinion, this should not be the criteria of choosing SQL over NoSQL. Now, let's see some more information about the NoSQL databases. So, see, NoSQL databases, first and foremost important thing is they have unstructured data, right? But NoSQL databases belongs to a family of databases. So like in the relational databases, right, it's normally a databases which store the relational databases, and some of the example of relational databases are MySQL, Postgres, SQL Server, right? But NoSQL, the term is an umbrella term. It in-houses multiple different types of databases. So there can be one of the database, probably key value, document DB, document database, wide column database, and the graph database, graph DB. So we'll talk about these databases in a different session. Here we are just discussing about the SQL versus NoSQL. Which NoSQL databases exactly to use, that we'll see in a different session. Now, let's come back to the point that I earlier made, right? In interview, generally prefer using the NoSQL over SQL. I'll give the reasoning why. See, what is the use case for using SQL databases? When the data is more structured, right? But even the structured data can also be sufficed through the NoSQL databases, right? Because NoSQL databases, even the NoSQL databases can have both structured and unstructured, right? Second point is on the scalability, right? When we have already seen that the relational databases suffer on the vertical scaling, right? They cannot be horizontally scalable, right? And that is one of the most important aspect for a system design interview, because whatever the system you are designing, right, you are designing for the scale, and you need to consider this particular fact that the data volume that you are going to process is enormous, right? And that's why it's always better to prefer NoSQL over SQL for those cases, right? Because the NoSQL databases are vertically scalable, right? Now, and the NoSQL databases performance does not degrade with increase of the size of the databases, right? So these are some of the reasons, and even nowadays the ACID properties are also can served via NoSQL databases, right? So that's why generally I advise to prefer NoSQL databases over SQL. Now let's see an example where the SQL databases can going to perform better and not NoSQL databases. So whenever we have a requirement of the analytical processing, let's suppose let's suppose finding the uh, top 5, let's suppose top 5, top 10, right? These kind of queries are best served via the relational databases, because most of the NoSQL databases are based upon the keys and values, right? So they does not have enough capability to process the range queries. Nowadays, even some of the NoSQL databases have the range queries as well, but their fundamental is on processing the direct update rather than doing the analytics query. So whenever you have the requirement of the analytics processing in the main database, then you can use the relational database over NoSQL. Rest in all cases, always prefer to use NoSQL databases. Now, let's see what other advantage NoSQL databases give. So, one of the prime advantage of NoSQL databases is you do not need to think about the schema upfront. Schema upfront. That means the schema can be changed. Schema can be changed. But here is one catch. The access pattern should not change. Access pattern means, let's suppose let's suppose you have a DynamoDB, okay, and you are let's suppose having the customer ID, okay, customer ID, and then order order details. Let's suppose you cannot next time you cannot say that I want to query on the product. Let's suppose order details has multiple things: product name, product price, and something else, right? So access pattern should be fixed. That means every time the access will be on the customer ID. It cannot happen the next time you come and say, yeah, I want to query this on the product name or product price. This is going to be very expensive with the NoSQL, and mostly it will be not supported. Especially the Dynamo does not support any such queries. And I'll talk why exactly Dynamo does not support those kind of a queries. So schema can be changing, but the access pattern needs to be fixed. And that is one of the problem with the SQL. In the SQL databases, you need to be upfront sure about the schema. You can add index later. You can add some of the index later as well to modify the access pattern, but the schema should be predefined. And any change in the schema will be very problematic. If you want to add any of the columns, or if you want to modify any of the columns, it will be very expensive in the relational databases. Now we have seen about the schema, right? Now SQL versus NoSQL. One of the important point of NoSQL databases, they are horizontally scalable, right? That means you can add more and more host, okay, and it will be able to process the query. And there are specialized type of NoSQL databases. Like we have seen document DB, we have seen key value, we have seen wide column, and we have seen graph databases. So we'll talk about all these type of NoSQL databases in separate session, and then we'll see which exact databases to choose from. Okay. But just to give an idea, there are different type of NoSQL databases, and each of them are specialized in different case. Now, now I'll talk about why most of the NoSQL databases does not allow those kind of a query, right? To change the access pattern, especially if I give the reference of Dynamo, right? This does not have any join, right? So at a first glance, you will see that the hey Dynamo does not have join, like, so we are degrading, right? SQL had joins, right? SQL, in SQL you can perform complex queries, but in Dynamo you cannot perform complex queries, right? Idea behind that is it does not give you the flexibility of going wrong. So Dynamo forces you to think in the right direction, right? It always asks for the upfront access pattern so that you can define the hash key and the hash key, also known as the partition key, so that your data should be well structured and your query can always result into a single digit value, right? It should not take more time. Especially with the relational databases, one of the problem is even the sometimes the query is not optimized, and you cannot realize that your query is not optimized, and sometimes that particular query can take even hours or days to run, right? If the query is not optimized, right, it can scan this entire table, and if you have such a big table, then it is going to take hours to process, right? And that is one of the things where people often go wrong, right? Because not everyone is so familiar with the query optimization, right? So many a times you can write a not optimized query, and which can result into processing of that query for hours. But Dynamo does not give you that flexibility altogether. It does not allow you to scan more than a certain data size. I guess that limit is 4 MB or something like that. So the chance of going wrong here is very minimal. Okay, and just one last bonus point I'll give you, right? So in system design interviews, right, always the ask is for the scale, right? And that's what we need to always rely on the horizontal scaling over the vertical scaling, right? And NoSQL databases are based for the horizontal scaling, and the relational databases that does not scale very well on the horizontal level, they scale on the vertical side, right? Now, and that's what generally prefer to use the non-relational databases, that is NoSQL databases, in system design interview, and we'll talk about exactly which kind of database you can use for what purpose. Thank you. And if you have any question, feel free to drop your question and I'll answer that question in weekend session. Okay. Thank you.